Hello and welcome, ladies and gents. This is going to be a quick video for e-learning day for Mr. Callan's class for Monday, April 20th. And as we scroll down, we see our objectives for the day. I will find the distance between 2 points on a coordinate plane. Distance between 2 points. So what do we got for the day? Watching a video, that's what you're doing right now, then completing some practice problems, and last but not least, summarizing your learning by doing the exit problems. Now I want to point out something that we have down here, and that is highlighted in yellow. Yes, I am writing answers on your homework, kind of like the odd problems in the back of the book. Check your work. Are you doing it correctly or are you not doing it correctly? And then keep going on if you're doing it correctly. Don't just skip problems because Mr. Callan's writing answers on there. I'm doing it to help you. So let's take a look at today's assignment, distance on the coordinate plane 1. And let's go ahead and come up a little bit. Focus on the homework for today. Step number 1, find the distance between each pair of points whose coordinates are given. Round it to the nearest hundredth if necessary. Now I'm going to take a look at the very first problem. It's got 2 points on here, -1, -2 in the third quadrant, 4, -2 in the fourth quadrant. But, folks, I don't know why it's even asking us to do this problem, because all I got to do is walk 1, 2, 3, 4, and 5 units straight to the right. In other words, I could just simply count. There's nothing else to do. But then I take a look at problem number 2. If I'm going to travel from -3, 2 down to +2, -1, I cannot just count the units. So here's what we're going to do. We're going to take what we learned about the Pythagorean theorem and we're going to make a right triangle. And if I look very closely at this, I'm going to now see a right triangle. I'm going to see a right triangle. If I look closely, that appears to be 1, 2, 3 units straight down. I'm going to go 1, 2, 3, 4, and 5 units to the right, leaving us with our question mark here. Now, because I have now introduced a right triangle, I can use the Pythagorean theorem. A squared plus b squared is equal to c squared. First step left for me to do is to insert the quantities that we know. We see that 3 appears to be one of the legs, the smallest leg as a matter of fact. 5 appears to be another leg, and that missing piece is the hypotenuse. We know it's the hypotenuse if you look very carefully. It is the longest edge, it is the edge opposite of the right angle. So that's how we knew that the hypotenuse was the missing piece. And so what we're going to do now is we're going to go ahead and solve for C. Before we solve anything, why not simplify? 3 squared is 9, 5 squared is 25. Even if I use my Desmos calculator, it would take care of that quite quickly to find that C times C is equal to 34. Oh, there you go again, Mr. Callan, working on your habits. What I should have done right from the very beginning is made an estimate. So if I see it goes 3 down, 5 to the right, this should be a little bigger than both of them. I'm going to guess about 6, but I'm not quite sure. Let's go ahead and find out now. So C times C is 34. That's way bigger than 6. Oh, that's because we have C squared. We don't want C squared. Now the opposite of a second power is going to be a second root. So let's go ahead, as long as we're fair to both sides, we're going to take the square root of 34 is equal to the square root of C squared. Now, if you recall from a few days back or from a few months back, Anytime you have a second power in an equation, many times you can have two possible answers, but you can't have a negative length here. So we know the answer is going to be positive. Meanwhile, square power, square root cancel out, leaving us with C equals. Going to my calculator, if I type in the square root of 34, it's going to equal to 5.830951.895. And goodness, folks, if it's that long, almost always it's going to be something crazy, ugly, irrational. But the directions asked us to round it to the nearest hundreds place. So we can go ahead now and identify our final answer as being about 5 holes in. Is that closer to 83 or 84 hundredths? Well, it's quite close to 83 hundredths. Please notice this is a coordinate plane. It doesn't say feet, it doesn't say inches, it doesn't say centimeters. So we're simply going to write units. And as I wrote, I can check that off at the bottom to make sure that works. So you can see how problems number 1 and 2 have similarities. They do both want to find a distance. You can see that distance between the 2 points with a purple line segment. But that's where the similarities pretty much end. Problem number 1 was a straight count. You just walk 5 units straight to the east or to the right. I have had students in the past, for problem number 2, we made a right triangle. I've had students in the past say, well, Mr. Callan, hold on. What if instead of going down, you went up, and instead of going to the right, you went to the left? Would that in fact have changed our particular problem? That's a great question, but if you notice, even if you go straight up 1, 2, 3, and if you go to the left, 1, 2, 3, 4, 5, it is the same triangle, a congruent pair of triangles, you could say, whose legs are 5 and 3. And therefore, you would get the same answer of 5 and 83 hundredths units. Folks, again, I put the answers to a few problems, not all of them, but a few of them. So I want you to continue on with this. And as the overview stated, if it's too quick, well, don't forget, do the exit problems found on your Google Classroom. And if it's too quick, not quite the 25 minutes that you need, looking for a challenge, take a look at these Khan Academy problems. That'll kind of get you ahead for Wednesday's stuff and talk about something called the distance formula, which will use the Pythagorean theorem and the right triangle. All right, folks, take your time and do well. Let me know if I can help. Just email me or message me and we can set up a tutoring. See ya.